Manisha Bharti, I think you have been removed by the system automatically uh, for the recording. I mean, system has removed you, so I will ask you to rejoin. Manisha Bharti, I got a notification from the system that due to some technical problem, when the recording will be started, some people may be removed. So Manisha Bharti is removed. So any one of you just send a message to Manisha if you have her contact with you to
Yes,
rejoin.
sir.
Okay, you have sent the message to Manisha. Hmm. So,
Hello, sir.
uh, so let me start today's class. Actually, today's our topic of discussion will be regarding dynamic memory allocation. I told you so many times that this is very, very important because in real life, we handle the uh, data structure with the dynamic memory allocation strategy. Why? Same question, that there are some constraints with the static memory allocation. For example, the feature we used, that is array. There are some constraints. In array, I repeat, I think all of you know, still I'm repeating this. This array has a constant that we cannot modify the size of the array, means the number of elements we will be putting in the array, we cannot modify its size. Means we have to know we have to know from beforehand that how many data or how many elements or how many records we will store in our database. So that should be known beforehand. In these cases only, in this type of cases only, we will be using array, right? Because during execution, we cannot allocate the memory size anymore. Maximum size will be fixed. But in real life situation, it hardly happens. We really don't get to know the number of records we will be handling with. So in real life, this static memory allocation we will not prefer. We will prefer rather the dynamic memory allocation. Means during the runtime, during execution of the software or during execution of the program, you know that a software, what is a collection of so many processes or so many programs, right? So, during execution of the software, we can allocate the memory as and when required. So that is all about the dynamic memory allocation. Technically, there is a feature in this language. It's called linked list. So with the linked list feature, we will be handling this dynamic memory allocation of the records. So let me start a presentation which where we will explain theoretically what is this linked list all about. See, topic is data structure and algorithm linked list. Okay, let me say something before that. Linked list, by the name, if you use a common sense, you will uh, uh, come to know that Uh, linked list means a list. It's a list means so many records or so many elements we will put in a list. Now, why it is called linked? What happens in array? If you go by the definition of array, you know that array is a collection of elements, collection of homogeneous elements, a collection of elements rather, in a contiguous memory location. Contiguous means a continuous, where each and every room of the array will be the continuous and consecutives. If we declare an array with 10 integers, if I consider that if an integer data takes 2 bytes of space, if we consider, then it will take 20 bytes of space, isn't it? Here also in linked list, if we create a linked list which will contain 10 elements, 10 data of integer types, here also it will be it will take 20 bytes of space. But what is the difference? Here, in case of array, it will be in contiguous memory allocation. If it starts from the memory location 2000, it will end in 2020. 2000 first for the first element, then it is taking 2 bytes. Then the next 2 bytes means the starting address of the next second room will be 2003, right? 2001, 2000, it will be 2002, 2000 and 2001 is allocated for. I'm telling about the memory address. If I consider that the memory address starts from 2000, means where we have declared the memory, declared the array in memory. Let's consider that this array has got a memory address, starting address 2000. Then first elements of for the integer, first integer will take 2000, 2001. Second element will take 2002, 2003. Third element will take 2004, 2005. Each and every element is taking 2 bytes. So in this way, it will be allocated in a continuous and a contiguous memory allocation. But in case of linked list, it will not be stored in that way. It may, because we are not allocating all the elements in a single time. When, as and when required, we are allocating the memory. So wherever the processor will get the memory space vacant, it will store the data, that particular data on that memory location. So maybe the first time it has got 2000 to store the first element. You cannot make sure, it's not guaranteed that you will get the next room vacant for the next time. For the second element, it may get any another location, a different location, let's say 1500. For the third one, it may get 6400 in this way. Now, the issue is that we are getting 20 different memory locations for the 20 elements in linked list. But how to keep track, how to know that which one is the first one, which one is the second one, which one is the third one, which one is the last one, and how to relate between, how to connect these elements between themselves, among themselves. So I must have a connection, or these items or these elements must have a connection within themselves. So I have to establish a link between the two elements. Here we will not say the element, we will say rather the nodes. Each and every element will be called as a node. The element may be a single data, element may be a multiple data, like a structure, right? Like a record, 20 records, if I mean, then 20 records has to be connected within themselves, right? So there must be a link between the nodes. Whenever we will be creating or we will be getting a memory location as per our requirement, when we will be going to create a node, we have to, means our program will establish a link between the node we are going to connect with, right? So each and every node must be connected. So there must be a link between all the nodes. That's why it's a list, but it's a linked list. Okay. Because the nodes will not be the consecutive. It may be of different locations. Now, are you the screen is visible? The presentation.
Yes,
Yes,
sir.
sir.
Yes, sir.
So a linked list is a sequence of data structure which are connected together via links. In a single word, it is defined. Linked list is a sequence of links which contains items, means nodes. Each link contains a connection to another link, what I just now said. Linked list is the second most used data structure after array. Following are the important terms to understand the concept of linked list. One is then a link, each link of a linked list can store a data called an, each link called an element. Actually, it is, you can call it as a node, which will contain the data. And next is each link of a linked list contains a link to the next link called next. Means here the variables rather will be giving, we can say this is the next actually gives track of the link, and here link actually it is called node. So it will be better if you call it node. So node contains a record. It may be a single data or it may be a multiple data, right? And as a whole, the entire list will be called linked list. A linked list contains a connection link to the first link called the first, and definitely the first item will be called the first or root. Basically, we call it root. Root is called root node, means the first node of the list. Okay. Now linked representation. It is called root or head. So many authors maintain so many terms. When we will be writing code, we will call it root or head. Okay. So this root or head actually is not a node. Rather, it holds the base address of the first node, means root node. This is root node and this is the address of the root node. Got the difference? Means say if a node contains free data, means a record of a student. Okay, I mean the name of the student, roll number of the student, marks of the student. So all these are will have a pattern of structure. So each and every record will be called as a node, and here the address where we will keep the address of the first node the variable which will contain the address of the first node will be called head or root. Got it? So head or root is not a node. Rather, it contains the address of the first node or root node. It contains the address only. And see, it is a second node. Let's say this first node has got the memory location 1000. Let us assume. And when we are going to create another node, when we are going to keep another record, which will be after the first record, means as a second record, it will not get its next location. It may get any location from the memory, wherever it will get a free space. So let's say it has got a location 5000. It is getting a location, means base location, okay, 1000, and it has got 5000. So how to connect? Because if you pictorially, if you consider a memory as a matrix, okay, so you can see that it is a different row and location. So I have to connect this node with this node. So there must be a connection to the next field. Actually keeps track of the connection of the second node, connection between the first node and second node. So if if the second node has the base address 5000, so we will keep here the 5000, means next is a variable which will hold the value 5000. Let's say in the third node, if it has got a location 3000, right? Okay, any arbitrary location, let us assume that the third node has got a free location 3000. So here means the next part of the second node must hold the value of 3000 to establish the connection. So pictorially we can say that this node, this next, is pointing to this node, base address of this node, or this next is pointing to the base address of the third node, this next node. So my question is, what type of variable we will declare for this next? It is a data items. It may contain one data or it may contain more than one data, and it may contain heterogeneous elements. I can put integer, character, float, whatever I need for the record according to our design of the structure. Definitely, if it contains more than one data types, okay, so it must be declared as a structure, because structure can only hold the heterogeneous data types. Okay, so my question is, what will be the type of this next variable? It is a variable which is holding the address of the next node. That's why it is called next, a meaningful name. Next is a variable which is keeping track of the next node, address of the next node, rather base address of the next node. Okay, so my question is, what will be the type of the next variable? Who will
Sir,
answer? Hmm,
sir, pointer variable.
exactly, absolutely right. Because all of you know, na, so many times I told you that the variable which can hold the address of any variable, it must be declared as a pointer variable, right? Any other normal variable cannot hold the address. A normal variable can hold the data only. But a pointer variable can only hold the address of any variable, isn't it? And what type of pointer variable it will be? It depends on the what type of variable it is pointing to, isn't it? So the next must be of a pointer variable. Good, Shan.
Thank you, sir.
Hmm. So as per the here, yeah, for example, I have terminated. So I this way I can add multiple nodes, and it is exactly actually it exactly happens in real life now. The example I mentioned in the last class, that if an relay reservation system, right, or if a banking system, the system really should not have any idea how many uh, number of passengers or how many number of customers it will handle, right? So when it may add number of uh, elements, n number of records. So it is the memory will be must be allocated dynamically. We cannot fix the size beforehand. Here a pictorial means symbol you can say now. Actually, it quite resembles with your electronic circuit, right? A circuit gets terminated with a null, isn't it? Null is earthing. Here, see, this is actually symbol of earthing, right? So null means here there is no node as of now. There is no node after this node, so it will be the last node. I can add any another node when I will need it, when the system needs it. But last node is determined if the next variable of the node has the null value. Means there is no node after this, so I can claim that this is our last node present in present at that moment, right? If I need to add another node, then the next will have the address of the next node, and that node will be the last node. Then I have to explicitly put the value of the next as a null. Okay, like why is we terminate a string with a null character. Okay, so as per the above illustration, following are the important points to consider. Linked list contains a link element called a first. Each link carries a data field or fields, number of data fields or a single data, and a link field called next link. So each node contains a data field or some data fields, a data part, two parts are there. One is a data part, another is the next part, right? Each link is linked with its next link using its next link. Last link carries a link as a null to mark the end of list. Just now I said, right? To mark this is a last node. To mark this is the end of the list is marked as the next value of the next will be null. Okay. How many types of linked lists are there? Mainly, there are three types of linked lists. One is simple linked list, one is simple linked list, another is double linked list, and the third one is circular linked list. So we will discuss all these linked lists one by one. Once I will complete the first one, I will go to the second one, then the third one, right? So, and for each and every type, we have to write the code also in practical. Okay. And in linked list, you can consider that the 30 to 40% marks out of 100 you will get from this chapter linked list. It may be from the single list. It's I mean simple linked list also called sometimes single list. Okay, it is a synonym. Double list and circular list. The question may come from any one. A question may come from three types also. There is another subdivision for the single list or doubly list, that is an doubly circular list or singly circular list. Actually, circular list is called single circular list, but we can design a a circular linked list with doubly linked list also. This is a subdivision of this, right? So basic operations will be this: insertion, add an element at the beginning of the list; deletion, deletes an element at the beginning of list; display the complete list; search, searches an element using the given key; delete an element using the given key. It's not means it's not mandatory that only we have to give the name. We have to maintain this name. Here, just in simple words, uh, with some implications, so we can uh, define another implication with some another word, another name, right? So that I will discuss when I will be writing the code. I'll be showing the code. It's up to our choice what name we will select for these different operations. Basically, these are the operations or manipulation of linked list. To manipulate a list, we have to, right? We have to go for some operations, list of operations, right? Or that means in each and every operation the will be of the form as a function. So we will write different functions according to the different operations to manipulate a list. Okay. Uh, Now my question is, I have a question. How we will define this node in a to write program? I have to define means when I'll be coding, right? I have to define this node. Now, how to define a node means what will be the type of this node. So this node isn't variable, no? So what will be the type of this node? Tell me.
Sir, ADT.
ADT is definitely, but what kind of ADT will be there? What kind of ADT will be this? Got my question? So actually,
Sir,
theoretically, theoretically, I've explained that we are dealing with different nodes, and this what it will be the type of these nodes. It will be array or structure. It will be a structure, isn't it? Because we are putting different types of elements. Even if it contains a single data, let's say our node, each and every node contains a single data type, let's say integer. But another field is there, that is a pointer variable. Next is a pointer variable. So different type of variable we are getting, even if we have a single data element of a single type. Say it is an if it is an integer, so it is a pointer. So pointer becomes a different type of data with this. So where we can put the different data type? Definitely it must be a structure, isn't it? Got it? Hello,
Yes, sir.
Shanton?
Yes, sir. Yes, sir.
So it must be a structure type. Okay. So what will be our type of structure? That we will that depends on the requirement, right? Means if we according to the but what will be the attributes or fields of record, right? So I have to put these fields here. So for our convenience we will take a single data. If you can handle with a single data, you can handle with multiple data, right? So our main focus will be to write a program which will maintain or which will manipulate an entire list. It may be a single type or it may be a multiple type. It doesn't matter, right? If I deal with a single type of data, it automatically it will be dealt with a multiple data, right? Just to assign the values of the data here, right? Different fields. Okay. So insertion. Say this is an existing list of two nodes. This list contains two nodes. Now I want to insert a node between these two nodes. Let me so happen. Right. Got it. My requirement is such that I have to insert a node between the first and second node. So what will be the steps? What will be the steps for I need to follow? If I connect this node, means let's say it is having the location 1000, it is having the location 3000. So our next is currently holding what, 3000, isn't it? What I explained just now.
Yes, sir.
I have created another node which is yet to be linked, which is yet to be inserted, right? So that's why it has put a different location here in my picture. So let's say it has got a value 2000. So what manipulation I have to maintain so that all these three links get the actual sequence and gets linked properly. Could anyone explain? So currently it is null because it is single node, right? Next is holding 3000. If I make it is 2000, if I change the value from 3000 to 2000, means this node will be connected with this one, right? Got it? Hello? Hello?
Yes, sir.
Are you understanding?
Yes, sir.
So I have to do this one, but if I do this, this will cut off, this chain will cut off. I will not be able to trace this node. This connection will be lost. If I simply establish the connection, if I simply keep the connection, put the connection off from here and establish a connection with this, so this will be cut off now. So the sequence will be, first I have to connect this node with this node. So currently this node will be pointed with the first node and the node we are going to insert. Okay, got it? Then we will change this link, we will cut this link and change this link with this one. So it has got the connection with this and it is getting the connection with this. But first I have to, means first I have to change this, next I have to assign the next value of the next field with this address. So I have to put here, as for according to my example, 3000 here. It is 3000 the base location. So if I put 3000 here, so it will be connected with this one, right? Isn't it? It implies that this is the next node of this one. Then I will do, or then I will change this next with the 2000 with this value, with this value 2000 with this. Got it? So the sequence I have to always maintain. This is the main issue. This is the main point we have. We will always maintain. Otherwise, manipulation will not be successful, right? This is what I have explained pictorially. It's being represented here. First, I have to connect with this is our first step. I should look this new node. This I will be explaining the code later on. After we do this, I have to change this. Got it? Just what I explained. Understood?
Yes, sir.
Yes, sir.
Understood.
Yes, sir.
So we are getting this node inserted between the first node and this node, right? So now onwards it will be our second node and it will become the third node, which was previously was our second node. Okay. So this is the way of insertion. So when we will be writing the code for inserting an element in any position, we will do that delete operation. Let's say our target node is this. Like insertion operation, it may so happen I may need to delete this one, isn't it? So if I how to delete means I have to establish a connection between this node will be this node will be the second node of this one. It will not be the second node anymore. So simply I will change the next part. Currently the next part was holding 2000 according to my example. It was having 1000, it was having 3000, it was having 2000. Currently it is having 2000 next. Okay, so I will simply change the value with the 3000 directly. So conceptually this link, this node is cut off and this link is established with a new link, new value, this one. Got it? Pictorially it is shown here. The target node is deleted. Target node is deleted. That's all. And this way I can also delete this any node. Okay. Reverse operation I will explain you later when we will take a separate class which I will show you a program or I will ask you to try for that when you will be accustomed with the code, that is that manipulation of linked list. I will ask you to try for that reverse the list, means after we reverse the list our last node will be the first one, the first node will be the last one, and the link will be the means link will be the reverse, right? Reverse. So that's all with the theoretical part. Just an overview, theoretical overview I have given you. But I believe that until and unless we convert it, a theoretical concept, into the practical one, until and unless we write code, you will not get the thrill. You will not be interested, or you will not store it in your memory permanently, right? It will be only stored in the memory of your computer, isn't it? So in today's lab, uh, I will show you the pattern of writing the uh, program for single list, and this will be industry oriented. The pattern I will show you will be industry oriented. Not, you will not get my code, the pattern I will be writing, I'll be showing. You will not get in any book. Can make sure, right? And wherever you will be getting, I have some my style, exceptional style. You will not get in any another uh, source. If you see, if you get to see, so you can be sure that that was my code, right? So exactly it will not be the same. If you get a same type of code, so you will get this. You will understand that was my code. Anyways, so I will show you. It will be very easy for you to understand. Otherwise, if you follow any book, you will be confused, because here we will be handling with pointer to pointers, not a single pointer, like double pointer we have to handle. But if you follow any book, it will be difficult for you to understand. So uh, how to take it easily, how to handle it, this double pointer, pointer easily, maintaining the industry standard, that I will show you in today's lab. Okay, so let's conclude the theoretical discussion over here. So we'll meet again in the your lab practical session. Okay.
Okay, sir.
Oh.